let's have a look at the first 5 MCQs of paper 3, right? Now in the first question, you have two prisms and they have the same refractive index and they are equilateral prisms. So if I start to mark the angles, since it's equilateral, every angle is going to be 60, right? Now you should understand it's a straight line. The entire angle is going to be 180. So 60 along here and 60 along here. This remaining angle is also supposed to be 60, right? Now, first of all, you should understand, now during minimum deviation, the refraction at here and the refraction at here are the same. And since it's equilateral, the ray is parallel to the base. Now, that's an extra information, no need for this question, okay? So, you should understand 2r is supposed to be equal to 60. So, from that, r is supposed to be equal to 30. And when I just plug into the equation, 1 times of sine I is supposed to be equal to root 3 times of sine 30, which means I is supposed to be equal to 60. Now what they have been actually question is, what should be the angle which the prism CDE should be rotated such that there's minimum deviation along this two. Now they have the same refractive index, same prism angle, so they should have the same angle of incidence. That's going to be the theory. So what we had actually do here is, we have to find the angle of incidence along here. Now when this is 60, now it's a minimum deviation, the angle which is emergent from here is also supposed to be 60 in the sense this is normal, so this angle is supposed to be 30. Now 60 30, this is going to be 90, so the angle of incidence towards this prism is going to be 0. It's just going to travel undeviated. So what we had actually do here is, we have to rotate CDE by 60. That means almost touching this surface, right? So that the angle which is refracted through here used to enter this ray, so this prism with an angle of 60, right? Something like this, right? Now when they are in the case of same refractive index, this is going to be the idea, okay? Right. Now let's have a question number 2. That means 3 ampere passing through 4 ohm and 2 ampere passing through this. If you consider the potential at A, now 3 times of 4 is going to be 12. So there's going to be 12 volt drop along him. Potential drop across him is going to be 12. Now you should understand, when the potential drop across them are the same, there won't be a current through R2. The reason is, the potential at here and the potential at here are the same. So there won't be a potential difference. So when V is supposed to be equal to 0, I is going to be 0. So this 8 ohm is just pointless, right? So we have to consider this network. So the 2 ampere current which was passing through R2 used to move through the 3 ohm as well. So the total current which is going to be here is 2 ampere back again. The voltage along here is going to be 2 times 3, which is 6 volt. So now this is going to be almost like a Wheatstone bridge. So here also there has to be 6 volt. And the total current which used to pass through this is going to be 3 ampere, entire current. Now if I consider the equivalent resistance between them are equivalent, 3 ampere current has to be passed through this, and such that the voltage is going to be 6 volt. So R equivalent is supposed to be equal to 2 ohm, right? It was complete inspired from 2005. I think it's MCQ 53, right? Let's have a look at that also. Right, now the question number 3 is that simple. Now that's related to radioactivity. Now you have a neutron and there's a proton, right? Now they haven't given us about the particles. Now you should understand, neutron is 1 0, right? And we have our proton as 1 1, right? So if I want to make it as 0, I have to have a -1. So that's going to be from a beta particle. And an anti-neutron particle is emitted, and an up-down quark has a charge of 2 by 3 an electron. And so 2 by 3 plus charge. And D is to have a -3, -1/3. So the addition of UUD is going to be 4 over 3 minus 1 over 3, which is 1, right? So every time remember, for proton UUD and for neutron it's UDD, right? Look at question number 4. Now in the statement A, they are saying us the gravitational potential of the block gradually reduces. Now you should understand that's a true statement, because why? The height of the block starts to decrease gradually, right? So from that, statement A is correct. Now if you understand, statement B is also correct, because obviously there will be no any liquid rise. The main reason is the upthrust acting in both the cases are going to be the same, right? Because the entire volume is submerged, so V rho Wg, and here is also V rho Wg. The upthrust is the same, right? So only when the upthrust changes, if it reduces, the water level decrease. If it increases, the water level starts increase. Upthrust is unchanged, right? So due to that, the water level remains the same. But how does the gravitational potential energy increases of water? If you look at here, when the block reaches to the bottom, there will be a certain volume of water equal to this, right? When the block reaches onto the bottom, the volume of water which is present here used to move to the top, right? So due to that, the gravitational potential energy of the water volume which was present here starts to increase. So from that, answer number B is also correct. Now if you look at answer number C is wrong, because why is, now when I just release this block in air, we are going to have only the weight as a downward force, right? But when I just release this in water, I'm going to have weight as well as upthrust acting on him, right? So you can see the force which is in the downward direction has reduced. So due to that, the velocity starts reducing, right? So if you understand, the velocity at point A will be much more less than the value when there is no air, when there is no water present, right? So right now, let's have a look at this resistors question. Now the only thing you should understand is, when there's a resistive path and there's a non-resistive path, the current is just going to travel through the non-resistive path. Now let's say if you're going to buy a product in a shop, you every time you consider the price value of that. The one with a lesser price, you're just going to buy it through that, right? So something like this, okay? A current which used to transfer here, it's just going to move through this. Now you can see this path is has to be with some resistance, and this is a non-resistive path. It just traveled through this and through here, because you can see here there is going to be a resistor, so it's going to travel through this and through this resistor, because there's no option at all. Just going to travel through this resistor and through this and through this, because why? A non-resistive path, it's very easy, right? Now it's just going to travel through this point. And if you consider a similar diagram for this, so it's just going to meet only these sort of resistors which we have marked, right? So now the equivalent resistors diagram is going to be like this. These two resistors going to be presented here, and these two resistors are at here, and these two resistors are going to be at here. So if you consider each and every one are R, so when they are parallel, you should understand R by 2, R by 2, R by 2. Every time the half of them. Now if they are equal, it's going to be half of them. So R by 2, R by 2, R by 2, it's going to be 3R by 2.